Okay, we've made a start and we've got our first service kind of complete. We've still got more work to do on this particular service, and certainly if we go back and take a look at the spec that we're working towards, then we've got things that we cannot do just yet, as in dealing with microservice based things like emitting events and consuming events, and we've also got identity that we do not have yet that we need for certain endpoints that will require authentication. So we've made some progress. We've got our first very basic service, just a simple CRUD application with these endpoints, and we're returning the data that's specified in that spec. Now's a good time to save our changes into source control. Now you might have source control public repository preferences, but what I'd really recommend is you do use GitHub for this particular training course. We are going to use some GitHub functionality a bit later when it comes to continuous integration, and one great tool for doing that is GitHub Actions, but it does rely on you having a GitHub account. So if you do not have a GitHub account at this time, please do create one. It is free of charge. You don't need to pay anything to use GitHub, and it does provide us with some very useful functionality that we'll be making use of a bit later. You also need to have Git installed on your computer. Because this is not a beginner course, I'm going to presume you already have Git on your machine and you are reasonably comfortable with using it. And what we'll do first of all is we've got a bunch of code inside our application that we don't need to save into source control. If we take a look at the File Explorer, then we have these things like obj folders that contains a bunch of code, and we have a bin folder that contains a bunch of DLLs and stuff that's recreated every time that we restart our application. We don't need to save that stuff into source control because that's not code that we have written. We only really care about the stuff that we've created ourselves. So what we'll do to address that concern is that we'll create a git ignore file. But first of all, let's initialize our Git repository. And we can do that by using the git command and say git init, and this initializes an empty Git repository in this location. What we can also do is add a git ignore file, and the .NET SDK provides this now that's suitable for a .NET application. What we can do for this is say .NET new git ignore, and this is going to create a git ignore file. And if we take a look at this, then inside the file system, what we should have is this git ignore file that ignores a whole bunch of things that we don't need to save into source control, like the bin folder, the obj folder, that kind of thing. We don't need to adjust this. This is fine. What we can do then is we can commit our changes, and we're going to use git add followed by a period. And this is going to change all of the not ignored stuff and save that into, or at least add it or track the changes that we've made inside Git. So we'll use git add followed by a period, and then we can commit our changes into our local source repository with git commit m-m for the message, and we'll say end of section 2 as the commit message. And that's gone ahead and taken care of that. Now we'd also like to store these changes in a public source repository like GitHub, just in case we have a catastrophic hardware or hard disk failure. Then that would lose our local Git repository, and all our hard work would be for nothing. But if we use a public repository like GitHub, then our changes are saved in the cloud somewhere, and if we replace our computer, then we can get back all of our code from a public repository. And this is the one that I'm using on this training course, and I really do heartily recommend that you do the same. So please do create an account if you do not already have one. Once you've got past all their security requirements, such as two-factor authentication, which is required for GitHub nowadays, we can then go ahead and create a new repository, which I'm going to do now. And we need to give it a name, and I'm going to say Carsties as the name of this repository. I'm going to make the repository public, which means anyone on the internet can see this repository, but they're not allowed to update the repository. It's read-only when we use public. But as long as we're authenticated, then we can make changes to our own repository. I'm not going to do anything else with this for now, and I'm just going to say create repository. And once this has gone ahead and done its thing, then it gives us some things that we can do. The Git branch, or we've done the first 3 things on here. We've got the Git in it. We're not going to worry about a README for now. I'll add something later for that. And we've given our commit a name and committed it locally. This Git branch allows us to rename the branch. If your branch was created using master, that's probably going to be removed from the terminology at some point in the future, and they recommend you change it to something like main. And if I go double check, then this is the name of my repository, main, which is fine. But if yours is something else like master, then you'd want to use this command to change it to main. Then we can add the remote repository to our Git, which uses this command. So git remote add followed by the repository location. So I'm just going to copy that into my clipboard and I'm going to add that. And then we can say git push origin main. And it uses the address here to push our code up into the GitHub repository. And there we go. It's now located on our public Git repository. And if I refresh this page, then we can see the code that we've added. And I've got my VS Code stuff there, which probably could have been ignored, but I'll not worry about that for now. And we've got our source code along with all of the code that we have written. And that brings us to the very end of this section, and we'll wrap up next with a summary. Okay, we've made it to the end of the first coding section, which was section 2, and we've created our first microservice, and we now have a simple API for the auctions, which is of course a CRUD application, and we haven't put any complexity. We haven't used patterns like the repository pattern or the unit of work pattern to do this. We've kept it at its most basic level, and we'll take that approach until we don't need to for each of the services that we build. They're just going to do one job, and in this case this service, its one job is to be a relatively simple CRUD application so that users can create, read, update and delete auctions. We've seeded some sample data into our database. We need that. We've got to have something to work with, and we've created a Postgres database and used Docker Compose to do that. I'll once again reiterate the importance of using Postgres for this. Please do not use SQL Server. Even if you are really tempted to do so, you will run into something that you cannot do later if you're using SQL Server, depending on when you're viewing this course. And it's related to something we cover in several sections' time, and the service bus. So please do stick with Postgres. And we've also used Postman to test our API, and we've checked the code functionality is working. If you do have problems with any of your endpoints at this point, now is the time to fix them. It's not a good idea to move forward if you've got a problem in one part of your application, because it's not going to be magically fixed in the next part. So please do ensure that things are working as they're supposed to at the end of this section to give yourself the best possible chance of things working as we build more into this application. Coming up next is going to be our second microservice, which is going to be for search. Okay, welcome to section 3, and in this section our goal is to create a second microservice, and this service is going to be responsible for search. So coming up in this section, we are going to create this search service. Once again, this is going to be a web API type of project. It's going to have a controller and it's going to have API endpoints, or one API endpoint in this instance. We're also going to use a different database technology for Lisp service. Not because we necessarily have to for what we're doing here, but the MongoDB does have, or not MongoDB itself, but .NET. There is a package that we can add that makes it easy to add search functionality and also pagination functionality as well. So that's a pretty useful thing to add, and we're also going to take a look at how we can communicate basically at this stage between two different services. The goal of microservices, certainly at this stage, is that our services can operate independently and can be developed independently of each other. But of course, at some point we're going to have to start thinking about how we get our data consistent, or at least the data we want to be consistent between the two different services. And we're going to introduce a very basic form of communication, synchronous communication, in this particular section. In the next section, we're going to take a look at asynchronous communication and service bus and all that kind of stuff. But for now, just because we're starting off as simple as we can do, we'll take a look at that way to get data from A service to B service. And if we just look at the big picture of our application at this moment in time, well, where we currently are at is we have our auction service and we're about to create our search service. And in the big picture kind of things, well, that's not very far in the progress, of course. We don't have a lot of this stuff. We don't have the event bus, we don't have a gateway, we don't have the client apps, and I'm saying we've still got a fair bit of work to do. So we're just going to focus on the search service for the time being. So if we take a look at where we're going to be at the end of this section, we're going to have our auction service, of course, that's still going to be up and running. And in fact, we're going to kind of pretend that the auction service does not exist, because we should not need that to develop our search service. And the Postgres database, the big difference between the two database technologies we're using here, well, Postgres is a relational database and MongoDB is not. It's a NoSQL database. And whilst Postgres uses tables and related tables for managing the data, Mongo database is really just a document store, and it stores our auctions or items as documents in that database, and it's not related data. It does have its pros and cons, and in very simple terms, if you're asking the question, is MongoDB faster? Well, the answer to that is, if everything is equal, then no, they're pretty much the same. But if we think about what we have at the moment in our auction service, we do have a relationship between the auction and the item. So each time we request an auction from that database, then sure, Postgres is going to need to perform a join operation to join the auction and the item together before it returns that data. In the case of our MongoDB, it's just going to store documents of the items, so theoretically it should be slightly faster when it comes to requesting documents from that database, because it doesn't have to do the extra work to join those tables. Now, the idea of what we're doing here is that we're going to be functioning, just concentrating on building and developing this service, as though we don't know anything about the auction service at all. Our goal is just to get this search service operational. It can start on its own without needing an auction service. Of course, at some point we're going to need to start thinking about how do we get the data from in here over to our MongoDB database, and that is going to be coming up in this section as well. And we're going to take a look at really basic communication between services, something that you'll be very familiar with, which is an HTTP request to go from here through to here to get the data. So that's what's coming up, but you might be wondering, there might be an elephant in the room, and you might be wondering why I'm not using insert your favorite search database technology there. Something like Elasticsearch, something like Solr, for instance, a proper search engine for our microservices application. I did consider it, I did look at it, I did even try it out, but the complexity of these services and adding them really distracts from actually building the number of microservices that we're going to have in this training course. So I've chosen not to do so. Certainly in terms of Elasticsearch, I was running into all sorts of issues regarding licensing, which I do not want to get involved with on a training course at all. And when running on a lower powered machine, such as a MacBook Air, I was running into performance issues as well, because that's quite a resource hog, Elasticsearch, just by itself, even if it's not doing that much work in terms of indexing. So I've gone for a more simple solution to cover search for this application. One of the great things about microservices is that if some point in the future you wanted to use a better technology for search, then hey, you only need to swap the search service. You don't need to mess around with other parts of the application, because that's one of the pros of using microservices in the first place. So without further ado, let's get on and start building our second microservice.